Okay, this is just going to make sure that you got everything you needed to get out of the transformations investigation on Desmos. So I'm just going to go over what each transformation is and how it looks in the equation, just to make sure that you got everything that you should have gotten with Desmos. So you should have noticed that all of the examples are written in what form? What form is this of a quadratic? This is vertex form. So if you notice, they were all written in vertex form. That is the form that easily shows which way the quadratic moves. All right, first, talk about A was the first ones that you did. So the number in the very, very front. So if it was a number that was greater than 1, there was a vertical stretch of the graph. So think about a rubber band. So vertical is up or down, and then, so think about you're holding a rubber band and you stretch that rubber band up, the rubber band gets skinnier. So a vertical stretch makes the graph get real skinny. That's if A is bigger than 1. So like 2, 3, 4, 5. If A is between 0 and 1. So it's between 0 and 1. So like 1/2, 1/3. That is a vertical compression. Think about, this one's kind of tricky. Think about this like a spring. If I push on the spring, I'm pushing it down, and so the spring gets wider. And then the last thing with A, if it's a negative value, that is a reflection across the x-axis. So this just flips the graph over. So those are the 3 things that can happen with the A value up front. So if you look at the end of your Desmos investigation, this little sliders thing was there. So you could play around with changing like the A value. So this is less than 1. So see the blue? The blue is the new graph, and then the green is the parent function of x squared. So x squared, the parent function, hasn't had any transformations done to it. So you could have played around with the sliders. If you make it bigger than 1, notice how skinny the blue graph is. It just gets skinnier as the number gets bigger. And then if we make all those values negative, like there's 0.3, if we make it a negative 0.3, well, there we go. It's the same graph, it's just upside down. So all the negative ones, they do the same thing. If it's bigger than 1, it stretches. But if it's a negative, it's upside down and stretching. So that is, you can play around with that on that Desmos activity. So that's what A does. Okay. H is inside parentheses. So when you're inside parentheses, if we are a positive H value, we are going to move to the left. And if we are a negative H value, we are going to move to the right. So these are opposite of what you think. When I think of left, I'm thinking negative. But these are opposite because of the vertex. That's why they're opposite. So the inside number is backwards. So if it's negative, it moves to the right. And if it's positive, it moves to the left. Now that was also on here. So I'm going to change H. If it's positive, it should move. I got to make it. Should move the graph to the left. And then if it's negative, I should start moving to the right. Now notice, to figure out how many it moves, look at the original. The vertex is at 0, 0. So focus on where the vertex is. So if I do this right here, the blue vertex is at 2, 0. So it moved to the right 2. So focus on, when you're doing transformations, focus on where did the vertex move. The vertex of the parent is always 0, 0. So if you can figure out where the new vertex is, you can figure out if it moves left or right or up or down. Okay, so that's H, and then the last one is K. K is the number outside the parentheses. If it's a positive K value, we're going to move the graph up. And if it's a negative K value, we're going to move the graph down. This is not opposite or anything. It stays how it should. Positive moves me up, negative moves me down. So if we look, we'll take this H back down. If I change the K to a positive, it's moving the graph up. And if I change it to a negative, it's moving the graph down. At the end of the investigation, you also got to see where you can do all kinds of things. So let's say I make the A big. So it's stretching. I make the H positive, it's moving to the right, and I'm going to move it up. So you can do all kinds of things to the graph. So you can move it left and down, and we're going to flip it over. So think about, you can combine all the transformations together. All you need when you get a function is you just need to see what is happening. The number out front, if it's bigger than 1, it stretches. If it's less than 1, it compresses. And then if it's negative, it flips. If we add inside the parentheses, we're moving to the left. If we subtract inside the parentheses, we're moving to the right. And then if we add on the outside, we're moving up, and subtract on the outside, we're moving down. So those are all the transformations that are going to take place. Now these transformations, we're doing quadratics, so we're only looking at parabolas, but later we're going to do transformations with the square root function. All of these transformations are the same. Instead of a quadratic, it's a square root function. So it's really cool that A, H, and K do the same thing every time on every single